here we go. If you've just tuning in for the first time, this is Containers from the Couch, this weekly show where we get to talk about all things containers on AWS. And my name is Nathan Peck. You might have seen me on a few different shows so far. I'm a developer advocate working on the container services team at AWS. And today I'm joined by Kyle, who is a fantastic developer advocate for Bottlerocket.
Hi, thanks for having me. Really excited to be here. I've been working with Bottlerocket for a little over a year and a half. Today is actually my 3-year anniversary of working at AWS, which is
Congratulations.
Thanks.
3 years is a long time and a big milestone in AWS years.
Yeah. It's a bit like dog years. I think it's like every year is worth 10 years in any place else. So I'm at my 30th AWS year. But yeah, no, I'm happy to talk about Bottlerocket. Like I said, I've done a couple other things at AWS. I worked for the OpenSearch team for a while, about half my career here, so about a year and a half, and I'm about a year and a half in working at Bottlerocket. But for those who don't know, Bottlerocket's a container optimized Linux distribution, and it's kind of one of the best kept secrets at AWS. It's an open source project. But a lot of people look at it and they, I don't know what this is. I've heard about it vaguely. Some people confuse it with Firecracker, which is a totally different thing. So I just want to first start out and talk about like what set the stage for Bottlerocket to be created.
And maybe how does it relate to Firecracker? Because obviously there's like a little taxonomy there. Like there's Bottlerocket is a form of Firecracker, or like
Absolutely
what's
not.
the relationship there?
The relationship is basically a couple things exist. One, they're open source projects that started at AWS. Two, they're named after fireworks. And three, they're written in Rust. But the teams are separate. They're totally different. They don't work together. Right now, there's no integration between Bottlerocket and Firecracker. So they're two separate technologies, similarly named, came out about the same time, and 10% of my job is explaining they're different. So
there you go.
Whatever. But yeah, no, Bottlerocket is an operating system, and Firecracker is about micro VM, so it's more of a virtualization technology. So I think people look at that, they both involve containers, so maybe that's where a confusion is, but it is quite different. But Bottlerocket basically came out of this idea that containers are fundamentally how we're running software today. Like, I think that's not controversial for this show. And effectively, if you rewind the clock and look at how we used to run before containers, how we used to run applications, we would take a Linux instance and we would, it would be a general purpose Linux instance. So something like Ubuntu or Fedora, something along those lines, Debian. And then what we do is you would take that, you could install that same distribution generally on like a laptop or an instance or an IoT device or whatever, and then we would just start mutating it, right? Changing that distribution into something different at runtime. And that is kind of hard to do. We got used to it because it was the way we ran things. But when containers,
I'll be honest, I never got used to it. Like the number of times that I've logged into a Linux box and it says, there's 83 system packages available to upgrade, and I say, like yum, upgrade or whatever, and it gets through about halfway and it says like failed because this package like conflicts with this other package, and there's no path to upgrade this. And I'm like, oh my God, I just gotta like reimage this whole box over from scratch again because everything is irrevocably broken.
Yeah, it's true. And like that's a pain that people feel. And like we're kind of used to it when we're like working with our own laptops or anything like that. But when we start running production systems, we had to have a better way, and containers kind of provided that better way, right? Like it added a layer of abstraction. And so once we started abstracting stuff, the role of Linux in containers changed, right? Like you didn't need it to do as much, and you certainly didn't need to mutate it as much as we were mutating before containers came along. And to
be clear, when you talk about mutating, I think a lot of people, for some, this is a new concept. The idea that to think about a change to the system as being a negative thing. Yeah. I think for me, like when I first touched like containers on a Linux system, the sort of light bulb moment for me was when I installed a piece of software, and then I didn't have to uninstall it. I didn't have to undo any changes. I just stopped the container,
Get rid of it.
and the file system that the container was using was its own separate file system from the host. The
Yeah.
container sort of evaporates and disappears. I can reclaim the disk space that was used by the container, and that original host file system has not changed at all. And that was where I was like, whoa, okay, uninstalling is just as clean as installing because everything is sort of partitioned into its own individual file systems for each program. I was like, okay, that makes a lot of sense. You don't have to worry about these things conflicting with each other. I have to worry about it leaving behind dirty files on the system that's going to break the next time I try to reinstall something. I was like, wow, this is amazing.
And mutation's a one-way trip, right? So that's the big deal. When you start changing something, you might have some tools to remove it, but it's totally different. And once you start doing this, you're adding to the care and feeding of a Linux distribution, right? And like this is just general container stuff. But even when you take that away and you start using Linux to just run containers, which is what most people are doing these days, you still have that underlying care and feeding of a system that is both mutatable and is mutated. And that comes down to like configuration and managing configurations between different dependencies, maintaining, upgrading, as you were talking about. It's securing all that stuff. Do you even know what you are needing to secure when you have this? It's like this kind of unlimited surface area that like a Mandelbrot, and you can just, the closer you look, the more you realize you have to secure. And it's really something that is a lot to worry about.
Now, a lot of Linux systems though right now they're kind of a weird hybrid, right? You have on the one hand your original traditional like Unix Linux system that's living on the lowest level of the stack, and maybe you're using like yum or apt-get or something
Yep.
to install packages, and then you have the rest of your clean containerized, maybe orchestrated
Yep.
system, and they're kind of like mashed together. And
Right.
so my understanding is Bottlerocket is aiming to make this a little clearer, a little cleaner, a little bit
Right.
more integrated
Well,
experience.
the what it really came down to is when we started looking at that kind of dichotomy of having this clean system and then having this kind of dirty system underneath it, we started asking ourselves in the team. I joined a little bit after this, but could we reduce the number of moving parts? Right? That's a lot to even think about when you think about simplicity of running these things. If we have less things involved in it, then it's less to keep up with all that care and feeding. Can we reduce the number of variables that people need to care about, which is, kind of going to the whole serverless idea, but, this is a server operating system, so it's a little bit different. And then this is the other kind of big point here is, could we talk about how we integrate with the orchestrators, so ECS or Kubernetes, something like that, and make that is an integral part of the operating system. And it fundamentally changed how we thought about what we needed in an operating system and what it did.
That is interesting because when I think about that, the first thing that comes to mind is like System D, right? System D being something that's built into pretty much any modern Linux system. But System D is local to that
Mhm.
particular VM or that particular computer.
Right.
And the more modern and cloud-based approach is I have an external control plane that is essentially my System D that lives outside of the box, and it's watching over 10, 15, 20, maybe 100 different computers at once. So rather than having 100 copies of System D across 100 computers, I have one control plane that lives outside, and it is serving as System D for potentially 100 different Bottlerocket hosts.
Yeah, I mean that's an interesting parallel. It's not exactly like that, but like I think that's a good way of looking at it. And System D is very controversial to a lot of people because it integrated a lot of things in. But I think in a weird way, like System D on Linux systems addresses some of the same concerns that Bottlerocket does. We use System D in Bottlerocket,
Mhm, mhm,
but when you start thinking about the Unix philosophy, right,
mhm.
where you have these small components that they all do individual pieces, that's fine. And System D said, well, it's kind of gotten out of hand in the init system, so let's kind of consolidate those things together. And I was talking to somebody once, and they compared it to like owning a dog versus owning 100 hamsters, right?
Yeah, yeah.
Like the weight of 100 hamsters is probably less than a dog, but caring for 100 hamsters is a lot more work than caring for a single dog. So you want to have like this one thing that you're dealing with, and both Bottlerocket and Systemd kind of address that issue. But when it comes to like talking to the orchestrators, functionally, Bottlerocket was built from the ground up. This is something that's important too to know. Bottlerocket's not based on any other Linux distribution. It is its own Linux distribution. It doesn't have any of the cruft or anything else from any other Linux distribution. We have some relationship with Amazon Linux as far as our kernel, but that's just how the kernel was built. It doesn't. The rest of it's pretty different. But it was built from the ground up to not even think about some of the traditional things that you would do in a Linux distribution, and instead shift that point of view into something that is designed for containers, right? So if you don't mind, I'd love to share my screen.
Yeah, let's bring it
up. So I'm on the bottlerocket.dev website. This is the website for the project. And I want to talk a little bit about where kind of Bottlerocket sits, right? I'm going to zoom in a little bit here. Let's see here. All right. So this is just on the homepage of Bottlerocket Dev. You can follow along if you want to at home, but this is kind of where Bottlerocket sits in the entire position in the cluster, because this is where people get confused sometimes. In any orchestrated cluster, you have that control plane that we were talking about, right? Like this is how you do various things with it. And then you have, so when you're working with ECS or Kubernetes, you're talking to the control plane. And then in turn, that control plane talks to the data plane, and that's where the nodes live, right? And those nodes, this is an example of like a very simplified example of a 3-node cluster. We have 3 nodes here, and each one of those nodes has Bottlerocket. And Bottlerocket is the Linux distribution that is installed on the node and manages the containers running on top of it, or hosting containers on top of it. Common point of confusion is they think that it's like a base image for a container. Bottlerocket doesn't live there. Bottlerocket lives on the infrastructure itself. So for whatever reason, people kind of like, can I install Bottlerocket in my container too? And that's not what it does. The reason why you never would want to do that is Bottlerocket can only really take its orders from the control plane. So it cannot take orders anywhere else or from the containers that are running on it. So it has 2 purposes: take orders from the control plane and then provide the resources for containers to run. So it would be a bit redundant to have a container talking to the control plane. That's not how it works.
Not to mention try and do like containers inside containers and nested containerization. Sounds like a nightmare to me.
Yeah, I mean, I got a headache just when you said that. So the other thing to know is basically when you're thinking about this, this reduces the mission of what you really need to do, right? When you think about that, there's a whole host of things that are just not required. And so Bottlerocket has this idea of just doing those kind of 2 things: supplying resources to the container and then talking to the control plane. And as a consequence, we can reduce all sorts of stuff. And one of the things I want to show now is this diagram right here. One of the most important concepts and one of the things that strikes the most fear in people with Bottlerocket is Bottlerocket does not have a package manager. So traditionally, you'd have Yum or some sort of way of getting RPMs, apt-get, or Debian, whatever. You have some sort of way to communicate to some sort of central repository that would tell you what's available for your system, and that gives you the list to mutate, how you mutate it.
Right.
Bottlerocket works quite a bit differently. So if you think about that, that's a runtime feature, right? Mutation is runtime. Bottlerocket is a build time system. So this little animation has kind of 4 columns on it: platform, orchestrator, architecture, and version. And the way Bottlerocket works is we take each one of those kind of attributes and all permutations that make any degree of sense, we pre-build a machine image that you can select. So instead of going in and adding the dependencies that require you to connect to orchestrator, Kubernetes 127 as your orchestrator, that becomes built into the system, and you select an image rather than the other way around where you do it at runtime.
That
Now,
makes sense. Everything is already burned into these AMIs. So yeah, I just launched the Amazon Machine image onto an EC2 instance, and it's ready to go.
that's right. That's right. So when you think about this, and I'll go through each one of these kind of columns to talk a little bit about them. Like we have three platforms we support. We support EC2, kind of the majority of people use EC2. We have bare metal, so it'll run on actual hardware. So it's kind of the lowest common denominator, and then we support vSphere for people using VMware. Um, and then we have Orchestrator that you're working with, and we have Kubernetes and ECS as our two big categories. But Kubernetes is different enough between versions that each minor version of Kubernetes is its own orchestrator. And of course, we have architecture, which is important for most operating systems, but Bottlerocket has a few extra reasons for it being important, and then the Bottlerocket version. So when you're talking about this as an example, like you can see where EC2, ECS on ARM for version 1.14 is different than EC2 Kubernetes 126 for ARM for 114. So you're kind of just picking that pre-built thing up and then letting it go. But the one thing that I think people kind of misconstrue is that means that they can't do anything with it. And we'll talk about how you kind of configure it a little bit later. I think one other thing about this system, one of our engineers talked about how it's actually very similar to your phone operating system. And there's actually a lot of combinations, reasons why you would look at it and go, this is very similar to a phone operating system.
Interesting.
So, yeah, both architecturally and some of the tools we use. But if you think about this is an iPhone 14, when you update your system, right, you're downloading a specific image for an iPhone 14, and that has the drivers for the camera, for the screen resolution, the modem or whatever. And if you were somehow to subvert Apple's ability and install something for an iPhone 13 on it, it would not work. It would not have the drivers for it.
That makes sense.
This is very similar to what Bottlerocket does. So when you think about that, that's probably the best way to kind of draw an analogy to it.
And I see another similarity there in terms of the orchestrator as well. Like if I was to grab a brand new iPhone and I just log in on my iCloud account, it's going to go ahead and download all of my apps, that I bought off the App Store. Similarly, I feel like the orchestrator is doing something similar, right? I can provision this Bottlerocket that starts out as just empty bare capacity, but as it registers itself with Kubernetes or ECS, it's going to get stuff full of workloads that I have configured as part of my orchestrator.
Yeah, that's a great analogy. I've never thought of it that way. But for sure, that's what it is. And like you don't have to configure your iPhone to connect to the iPhone store or whatever iStore. It knows how to do that already. So I think the important thing to know too, when you're looking at this, it's pre-built and ready to go, so you can definitely start using it. But at the same time, this is starting to look really weird, but the important thing to know is your workloads that your orchestrator is providing, they don't really care. This is still Linux. We're still using the Linux kernel. We use Containerd. We use a lot of these same pieces. We're using kubelet on Kubernetes variants and the ECS agent. Most of these things are just that they will run on a traditional general purpose a node or a Kubernetes node, and they don't have any kind of knowledge that they're doing anything different. They're kind of blissfully ignorant. The only changes for your workloads are if you have host level integrations. So if you're doing something like where it really starts getting different is like you want to ship your logs out or something like that. That becomes a little different, right? So those are things that are different. But I do want to kind of like dive a little bit deeper and kind of I started going into this. I want to give you an idea of what the composition of a node looks like. So this is a Kubernetes node. This is what it looks like. And if you ignore the left side here of this side, this is going to look very similar to almost any other general purpose Linux distribution being used in a context of like Kubernetes. You start with the kernel, you have systemd, you have Containerd, the runtime, kubelet's the agent, and then you have your pods where your workloads are living. And where it goes off the rails for a lot of people is this left side. And Nathan, I know we had a few months ago a conversation about this, going,
Like,
why does it do?
Why is there 2 copies of containerd and then another control? What is
Yeah.
that?
And this is Bottlerocket has a cleaner separation of concerns, right? The right side is for your workloads, your orchestrated workloads. This is the kubelet in this case, or ECS agent, which that's down here, the ECS agent. So it's very similar. That's where all of the orchestrator level information is coming from. But then we have this whole other side called host containers, and it's a unique concept to Bottlerocket. This is where you do your administration, and this is where you do your operational workloads. This keeps it separate for a couple of reasons. One, you want to make sure that you are not doing anything that would risk like your orchestrated capacity that you're outlining. You want to make sure you kind of have a reserve tank. That's one reason for having the separate containerd instance. And then the other side is if something was to go wrong and you were to accidentally flush something, you don't want your operational workloads to be, all the containers to be dropped off of that. But it's a really important concept because if we go back to the homepage here, the other thing that scares people is Bottlerocket does not have a shell. And this elicits this view of like having this sealed appliance that you have no control over and it just does something. And that's not the case at all. Bottlerocket uses a different kind of out-of-band access method. So functionally what's happening when you want to basically interact with a Bottlerocket node, not through the orchestrator, you start a interactive session either through SSM Session Manager or through SSH with a container, and the container has bind mounts into the host system, right?
Yeah.
So it feels very familiar. I don't have a node up. I should have brought one up, but if you log into it, it feels like you're just entering into something that is living right on the host system, but indeed you're actually interacting with a container.
Now let me ask, because this is something that I'm not familiar with, but I'm kind of curious about. The binary for the shell itself is part of the container that gets launched, right?
That's right.
So this makes me wonder, like, for example, my favorite shell is always Z shell, where instead of a plain shell. Is there a way for me to launch this admin container or this this out of band way to launch bring my own shell with me?
Yep.
Basically say, I want to log into a system, and traditionally I log into a Linux system. The first thing that pops up is traditional SH shell, but actually I want to bring my Z shell with me because traditional shell, I'm like, nah, that's whack.
Yeah, no, and that's kind of a good question, but you can certainly launch whatever you want to. There's nothing really magical about the stock control container. That's what you're logging into traditionally when you're using
It's basically
this.
just a container that has a shell in it, and then it has bind mounts to the host.
You got it. Yeah.
Wow,
So you could put anything you wanted to into it, and you could have ZSH, or you could do something really wacky if you wanted to.
This is beautiful to me because there's so many shell customizations that I'd like to have in an environment, and the idea that traditionally I have to log into my Ubuntu machine or my Amazon Linux machine, and then I have to apply a bunch of bash profile, bash RC, or Z shell RC customizations to get the shell to where I want it to be. Whereas theoretically, I could burn my own container that already has all of my shell customizations in it, and bring that control container with me to whatever Bottlerocket system. When it starts up, my shell already looks beautiful the way I want it to. It has all my shell completions that I like.
Yeah, yeah, you can do whatever you want to there. And if you look in the Bottlerocket repo which is here, you can actually just see that it's just like a connection to ECR. It's just like an ECR string, and that's all it is. And you can make those changes, and that actually segues nicely into the other kind of strange thing is Bottlerocket. You don't modify actual dependency configuration files or anything in the host system. You do everything via an API, right? And this is not an API that's public, right? It's an API that is through privileged access through a specific Unix domain socket that, it has like all sorts of protections against it being kind of exposed. So as you would want to make that change, you would just be able to, pass in a different configuration setting for that control container, right? So all of that's configurable. So I think we should talk a little bit about the API, because that's the other thing that people kind of go a little bit, how do I even manage this? So
I think for people who are familiar with Linux, they're like, well, I got to go into the etc directory and find some conf files to,
never.
And maybe use some sed magic to, manipulate them. How is that different with Bottlerocket?
Yeah, it's totally not even present, right?
Nice.
Yeah, so you can't do it, and we'll get to reason like what ways we prevent you from doing it and how it's just not possible. But Bottlerocket uses an API. The API is REST-like. It's not quite a REST thing because it uses it doesn't use HTTP directly. It uses more of like just a raw socket. So it's not, you're not making requests in the same way. But we have a client built in called the API client, which is actually living on the host, but it's bind mounted into that control container. So you have access to it to run it from that control container or any container that you want to do. But functionally, what you're doing, we have a whole list of settings, and those settings enable you to make kind of these changes, and they're just like any other API. Like they can be idempotent and have all this kind of power to them. Whereas if you're modifying a configuration file like you normally would on a lot of other Linux hosts, if you apply something 3 times, you might have a non-idempotent response. It might actually do something differently. But behind the scenes, what Bottlerocket's doing is we're taking these settings and we are marshaling them into the configuration files as needed. So it provides an abstraction layer for all your settings.
Interesting. So the underlying host may still have a conf file sitting in an etc directory somewhere. But
yes.
I never touch that directly. Instead, I communicate to the API and say, I'd like to turn on this particular containerd setting, or I'd like to turn on maybe a ulimit or something. And it's going to take that API call and turn it into a configuration file mutation automatically.
Yeah, and it's interesting because it's not a mutation, though.
Oh, okay, it's not.
It's not a mutation. So what's happening is there is a configuration file, and whenever the host boots, it reads the configuration file and applies a change over top of it, basically like a layered file system. And so you cannot change the actual defaults, but it can read those settings in.
So the API is essentially changing the configuration value pre-boot.
Yes.
Such that when it boots up in a fresh state with that setting applied.
So that's a good point. I misspoke. It depends on the setting. Some of them do require reboots, right?
Right.
And some of them will basically change the active setting and can manage how those settings are applied to the system. So that's taken care of for you. So once a setting comes in, some of them may actually restart service, some of them may not. All of that stuff is taken care of.
That alone is pretty fantastic, because the number of times I would have to look up okay, which system service I have to restart for this setting to apply.
Yeah.
Do I need to reboot the machine for this particular setting to apply? Yeah. And to have one consistent API where I send a configuration change request, and then it understands how to actually apply that in a proper stateful way such that it persists. That's very important.
Well, and the other thing too, as far as persisting, there is some differences there. So Bottlerocket uses the API, and then it uses a configuration, pulls user data in, right? So there's different ways you can make those changes to the configuration. If you're wanting to have something that persists always, throw that into user data, but it's the same interface. It's basically just a tonal representation of the API that's kind of replayed at boot. So yeah, that's we're getting a little in the weeds on it, but
I love this stuff. The deeper into the weeds, the more it becomes clear how much better of an implementation this is, in my opinion. It's much better of an implementation than working with a traditional Linux system where there's inconsistent ways to do configuration. There's inconsistent ways to apply configuration or even persist it. Now there is one API which can convert your API settings into a variety of different configuration formats, obviously for different services,
Yep.
and can restart services on the fly as necessary. That's pretty amazing.
Not only that, it's strongly typed too. So
Oh, even better.
so when you try to pass in like this, what I've got on the screen here, and I try to pass in like Kyle, it won't let you, right?
Because it knows that is a Boolean value. It's not a
Right,
string value.
right.
Wow.
So this is all kind of applied for you. So it will stop you from doing some of these things. There are some areas where we can't know. So there is some weakly typed areas for sure, but there's a lot of times when you try to apply something and it will prevent you from actually making a mistake there.
Well, that's great because there's nothing worse than messing around with some settings in your Etsy folder and then going to reboot and kernel panic and nothing is
Yeah,
working and you're just like, well, this is done. I gotta
yeah.
wipe this machine and reinstall or launch a new AMI because I've completely broken this root file system.
And what's cool about that is like, most, like not every setting, but majority of settings are something you can live update and we can change the system. You can go in and these are objects effectively. So you go in and make changes to your working system if you want to. That's applying those changes as needed. Then what you do is you can grab the setting. So you can just do basically a get from the API client, get those settings out of it. And then you can start up your next node with the settings that you wanted, right? So it all kind of works nicely together. It's a nice, neat package on that. So you can kind of do that exploratory, interactively change things until things behave the way you want them to, and then later use that and apply that to a fresh instance and get the exact same result. So it really makes it more predictable, right? It's like deterministic, whereas it may not be if you're using kind of configuration files. So yeah, I mean, I appreciate that a lot. I've always struggled with like trying to understand the near unlimited surface area. But another thing, we'll talk a little bit about 115, which is our next version. It's coming out very, very
Yeah.
soon. But we did a major change in how we're initializing our network configurations. We went from Wicked to systemd networkd. Now,
Okay. Now
that was
that on the surface sounds scary. Like if I look at two Linux operating system versions and I say, oh, they're completely replacing the network stack, then I'm like, oh no, I'm gonna have to go through and tune a bunch of settings again, and it's
right.
gonna be potentially completely different configuration files, and I'm gonna miss something, and people are gonna be like, why is there extra latency on our endpoint? And
It's a pain, and sometimes you have different ideas about how things work, and like Wicked used
Mhm.
XML, right? Like that tells you a lot, right? And what systemd does not. But because of that, we're able to transition and not affect the user because it's all settings, and those settings didn't change. We know how to migrate between versions and roll back. So
Wow.
if you want to make those changes, like, you go in to do that, we can marshal from the settings back into the Wicked way if you wanted to, think about how that works. Well, this is, okay, I'm stretching a little bit. That doesn't work that way. But the settings are still the same, right? Because those are
So
boundaries.
basically, it's the same toggle input in my
Yeah,
user data, or it's the same API
yeah.
paths for configuring certain network settings. Like I imagine, like I don't know, like a
DHCP or anything
TCP
like,
frame
yeah,
size or something like
yeah,
that. And then, no matter what the underlying network driver implementation is, Bottlerocket is a convert that toml setting to the appropriate network
you
driver
got it.
setting.
Yep.
That's amazing. So
It's
even
slick.
even upgrading from one version of the kernel with a completely different underlying system to another one, nothing breaks or nothing really changes from my perspective.
Well, yeah, so I will say that there is two different concepts in Bottlerocket. There is an update, and then there is and then there's a migration.
Mm-hmm.
And I'll go back to the homepage just to kind of illustrate a point. Um, you cannot move automatically between different variants, right? Um,
Mm-hmm.
and so we have different lines that are there. So, for example, we're looking at adding Kubernetes 1.2.8 and Bottlerocket 1.15 that has the different Linux kernel version, have a Linux kernel 6.1, right?
Mm-hmm.
So that is you have to migrate those things, right? So we would not
Mm-hmm.
guarantee that, we'll talk about updates in a second, that you can't update those automatically. You have to manually kind of do a different node with that and drain it and all that stuff.
Hmm.
But your settings would probably be the same, right?
Right.
But we would suggest that you would, test it, because running a container on a different version of Linux is potentially a breaking action, right?
Right.
Uh,
Right.
Linux looks like it uses Simver, but it does not use Simver.
No, clearly not.
That's a hard lesson. So when we talk about migrating versions of Linux, right, like
Mhm.
that's where you want to have extra care. But the API has not appreciably changed in different versions, right?
Well, that is important because if the API hasn't changed, then there is nothing that I need to do if something breaks migrating to a new version. Instead, I open a ticket to the Bottlerocket team and I say, "Hey, this particular setting, Toml setting, doesn't look like it's being applied properly
Yeah.
in when I migrate it," and that's a bug for the Bottlerocket team to fix, not me having to dig in and okay, what was this wicked network driver
Yeah.
setting that changed?
Right.
So it's an
You're right.
offloading of that responsibility onto uh,
100%.
an AWS engineer who's responsible for tuning that Linux subsystem and making sure it responds to your configuration changes properly.
That's right, and that's right. And there's been times where we, like I said, some of this is strongly typed, so we wouldn't want to even remove some of these settings because that would like break the checking of that setting, the validation of that setting.
Mm-hmm.
And there's been times where we've taken a setting and said, okay, this setting is deprecated. It's no longer serving a purpose because we may have changed something underneath, and we'll say it's kind of a no-op, right? Like this is no longer there, but the setting still remains, and maybe we'll log something, that sort of thing. So, but we keep the API as stable as possible, and so people aren't getting this kind of I'm going to go in and do an upgrade, and then all of a sudden everything breaks. So, and just to focus one other thing, you can change between different like patch versions, so that's always okay. That's just an update, and we can talk about that in a second. But one other thing that I kind of failed to mention here, and we were talking about this host container thing, and you can customize it, I said. But the other cool thing is you can disable it and get rid of it, right? So that means you have a much slimmer security profile that you need to worry about, right? Like you have no way into that except for the orchestrator. So that's really, really powerful, especially as you talk about compliance and all these things. When you have to answer a question and say, how does someone access the host? You just say NA, right? That's you can't.
And to clarify, maybe for some viewers who aren't familiar with orchestration systems, when we say no way in, you don't have to have port 22 open to allow SSH. You don't have to do anything. And the orchestrator does not connect to your host. It's your
Yeah,
host connects to the orchestrator.
right.
So you launch a Bottlerocket instance and it connects to the endpoint for ECS or to the endpoint for Kubernetes, and it's the one who initiates that. So
Right.
there is never a single. You can actually launch a machine and have all network ingress turned off. It's not even possible to send a single network request to that machine. The firewall rejects all incoming traffic, and you can have a functional machine because it's the one that initiates that request outbound to the control plane.
You got it.
That's pretty amazing.
Yeah, and there's ways that you can like re-enable it. There's a couple kind of little circuitous routes that you can go that you can tell the orchestrator to turn this kind of basically create a short-lived container that has the same bind mounts, but it goes through the orchestrated layer, and then it turns the host container back on, the control container back on. So with that, you can like re-enable it, but you're still going through that pathway that is through the orchestrator that you have as much trust as you possibly can have on.
Yeah.
So
and that can be controlled with IAM access as well, and different
right.
policies inside of AWS to prevent you from even launching that container if you really wanted to.
Yeah, I mean, people do that, and you can just like kill things and bring them up. I think it's actually a good opportunity to talk a little bit about how updates work in Bottlerocket.
Yeah.
So Bottlerocket's really interesting from a perspective of how it does updates because there's two different methods. There's kind of the node replacement method. The node replacement method in Bottlerocket is just like any other node in an orchestrated cluster. You're just killing it, you drain it, you kill it, you replace it with a new instance entirely with an updated version of whatever operating system you're using. Bottlerocket can do that, that's no change. But there are circumstances where you wouldn't want to do that. Give you a couple examples. Bottlerocket runs on bare metal, so you can't do that if it's a physical machine in a rack. You can't just like, oh, it's out of date, let's unrack it and throw it in the garbage can and add a new one in. That doesn't make a lot of sense.
Yeah, it's not happening.
No, like how do you update your system? I just throw it away and buy a new one. The other thing that you might want to do in, for example, EC2 or something, you can have situations where there might be contention across your entire region for a specific type of instance, right? And it might be hard to get a hold of that instance again. So think about like one of those really fancy GPU-enabled instances, right? That there is a limited number of them and you have some sort of great workload that you want to run on it. But if you give it up, someone's going to grab it, right? So you have a vested interest in keeping that thing alive as long as possible.
Totally.
Yeah. So Bottlerocket enables that. We have an in-place update system. And functionally what that does is Bottlerocket has two partitions. One has your root file system that's running, and the other one is a kind of like passive or not running system. When a new version comes along, it downloads the entire operating system into that partition that is not being used. It sets a flag, and then on reboot, it swaps which one is the boot partition, and then it boots into the new partition atomically. So the other thing to know about Bottlerocket is that any version of Bottlerocket in the same variant is identical. There is no mutation. So if you have one instance running one variant, and it's Bottlerocket version number 1.14.3, and you look at another one, it's byte for byte the same software, right? This actually works around a problem that people have. It's a surprisingly large problem called drift. Host drift is essentially where you have something other than Bottlerocket or a similar OS that is running and has a package manager that's going up to a repo and grabbing a particular set of packages. So let's say you have a fleet of 1,000 nodes. The first 500 nodes get one version of a package, and then that upstream repository changes, and now it downloads a slightly different version. Maybe it's just a patch version, but the latter 500 of all your fleet is slightly different. It's running different software at that point. And in the best circumstance, you have a situation where you have to reason about what you're actually running for a variety of things, or you think about, is there something in the supply chain? And in the worst of cases, the drift has made something not functional, right? Bottlerocket eliminates all of that because either way you update the system, you're getting a byte for byte similar copy. So they will behave the same exact way.
Yeah, that is really ideal because essentially you're downloading a whole image from scratch every time. There's never a point where I'm saying, yum upgrade or something like that, and relying on it to download and install a series of different packages, because each time that happens, every time it's downloading another package, there's a potential failure point. Versus one failure point of downloading the new image and applying it instead of maybe 80 different CVE patches that are each their individual potential failure points.
Yeah, and this analogy I think was pretty apt when somebody said like, okay, it's like taking your car in for service, and they're trying to diagnose if it's the carburetor, fuel injector, or the electrical system or whatever, and they're trying to replace parts one at a time. Instead, Bottlerocket just says, let's put a new engine in, right? Every single time. Let's not worry about individual components. We'll just throw a new engine into it, and hey, because this is an update, maybe it's a better engine, right? You just get a new one. It makes it just much easier to reason about. And again, from a compliance standpoint, if you're looking at something and saying, what software am I running? It's very easy to confidently answer that, right? The whole thing is pretty easy. So, yeah. And then the other thing that I kind of want to hit on a little bit is about the immutability of Bottlerocket, because people hear that it's an immutable OS, and this scares people. But immutable OS is basically would be that you can't change anything. Bottlerocket is partially immutable. The root file system is immutable. This means that you cannot make changes to it. is protected by a piece of software called dm-verity. Again, comes from the phone world. dm-verity is a block level protection for the file system itself. So I'll swap over here to some more documentation as well. Let's see here, restricted file system. So functionally, all storage devices use blocks on some level. Those blocks represent some amount of data, and it uses this kind of cascading cryptographic hashing on top of it. So when one block changes at the top level, it cascades downward, and it then changes the entire state, right, of the partition effectively. And if the kernel detects any change at that root block, it reboots. So if someone, I mean, you can't make a change to the file, but if you were somehow to even like go to the lowest level system, make that change, it's just going to reboot. It's not going to do anything else. And this protects you from a lot of things as well. But only part of our file system is that way. We have a mutable side where we store things that you would want to. So things like logs and the images that you've downloaded, configurations that are done by our systems, and that's protected by SE Linux, right? So it's a really effective way of knowing what you're running, and then it gets even better in 115. We'll talk about that in a second. But
that makes a lot of sense. Now, and obviously for a host that is particularly being used in our container orchestrator, chances are even logs I'm probably exporting out of the system to a cloud log storage service as well. So
right.
The surface area there is fairly minimal, basically just like image cache, maybe,
Yeah.
Container image cache. Next time I reload that image, it's going to load up a little faster.
Yeah.
Something like that.
Yeah, and the majority of what you're doing, you have a very slim amount that you need to do that. Almost everything that is running on Bottlerocket is a binary. That's the other thing that's distinctive about Bottlerocket. It's built in Rust, and everything's compiled. There's a little bit of Go in there too, but it's also compiled. So there's no interpreters. There's none of this stuff that has to run. So we put as much as we can into the root file system, wherever logical, of course.
That is important. So when you say no interpreters, there's no actual shell built into Bottlerocket. So that means there's no way for me to get in there and supply it with a command to run to even attempt to mutate the file system, short of maybe trying to find like some sort of buffer overflow error or something that allows me to execute binary code. But that's going to be much harder than if I'm able to somehow get a shell that can actually evaluate commands on the machine.
For sure. Yeah. So when you think about that, I mean, the exploits that people use typically when they gain access to something, they're going to use an exploit that then it's going to maybe apply some sort of shell script or whatever. That opportunity is not there. You'd have to have a container to do that. There is so many more layers that are there to make it a lot less attractive, frankly. It's still possible. There's possible to do all sorts of things. I won't say that this is
some way to do it, but the goal is, as with most security, make it hard enough that it's not worth somebody's time and attempt to figure out how to break into your system or exfiltrate data or whatever they're trying to do.
Right. Totally. And the thing about this, when you have like all this compiled software too, think about the exploit that you could have where somebody could go in to a system and then modify a bash script by a character or two, right? That's so hard to understand what's going on. You could look at it for hours and go, I don't know why this is different. I have a different hash. I don't know what's going on. I don't understand the extent of it. That's not possible. I mean, like when you're talking about a compiled piece of software, it's a much tighter packaging of that. It makes it a lot. The security profile of it is, I'm trying to search for the right word, but it's
much stronger for sure.
Stronger, yeah. I'm always careful when I talk about security to not oversell anything.
It doesn't sound to me like you're overselling it. It sounds like there's a lot more layers of protection built in than actually most people bother to enable on their Linux systems out of the box anyway. So out of the box, as just the end user who just wants something that's secure without having to do a bunch of customizations. Like how many people even oftentimes enable all the SE Linux related related stuff that maybe comes out of the box with Bottlerocket as well.
Yep.
So you're getting something that is built with more security, and in fact backed by a bunch of AWS engineers who are security experts, especially if you're I would say like a junior level or mid-level engineer who just wants to focus on your application. I don't want to have to learn everything about SC Linux in order to run my workload securely.
That's what I was gonna say. I mean, like, I saw a video that was pretty great, and it was like, I don't like SE Linux because it violates my number one rule of security is it's hard to understand, right?
Mm-hmm.
And like, I think that's real. SE Linux is incredibly powerful, and
Mm-hmm.
I deal with it, and I look at it, and as someone who is not completely submerged in it every day, I find it hard to grok, and I think
Yeah.
I am not alone in that. So having these policies kind of set up for you in ways that policies can't be altered, right, at the host
Mm-hmm.
level. All right, it says it right here. That makes it so much easier to adopt that security posture in a way that you wouldn't, you could do on your own, but let's be honest, you're not going to, right?
Yeah, that makes
So
total sense to me. Now, we have a fairly limited number of minutes left in the time slot for this show. Do you want to talk a little bit about, I heard you hinted at a little bit earlier about a new version of Bottlerocket coming up. You
yeah.
mentioned like a change in networking.
Uh-huh.
Is there anything else that you want to talk about that particular update as a preview for our listeners?
Yeah, so in fact, this is still something that is relevant to the topic I'm on right now. Um, in 115 and for all the new variants, so I'll talk about the new variant for ECS, but the Kubernetes 128 variants, we're getting a new kernel version, but we're also getting support for secure boot by default. Secure boot, for those of you who don't know, and some people have some misconceptions about it or think about things like Windows, but secure boot in its essence is a way that you can effectively lock a machine or instance to a signed bootloader effectively. So you can say, I don't want to boot anything but what I have specifically said that it's there. Because right now, bootloaders are kind of the Wild West. And so if somebody, has a bootkit that they add to it, once you're at that level, you're at the lowest level of the system, and then you can make everything else look like it's normal because you have the highest level of privilege on the system.
Yeah, yeah.
Uh, so where it comes into it's really important is that secure boot starts a pre-boot chain of trust that goes all the way to your container orchestrator. So what you boot with is secure by every single step along the way. So the firmware validates the bootloader. The bootloader validates like the configuration file. The configuration file has the information to validate the kernel. The kernel has the information embedded in it to validate the dm-verity root hash. So you have this chain of trust that exists unbroken from before you boot to your container orchestrator there, because your container host is really sensitive, and you want to
Mhm.
make sure you have that really taken
So
care of.
that's actually very interesting. So basically, the Kubernetes control plane potentially, or maybe ECS at some point, can say, I can tell that somebody tampered with the bootloader on this host. I refuse to schedule any containers onto that.
Well, even more than that, it won't even boot. If someone
Oh,
has,
I guess that makes sense. It wouldn't even boot to register with the control
yeah,
plane then. Yeah,
that's right, that's right.
yeah.
So a huge level of protection there. So that's an important feature. The other things that are coming up on it, there's a few odds and ends, but I talked about the network change and how that's enabled by our settings. We have a built-in compliance checker. So Bottlerocket has a CIS benchmark, which is kind of a computer information security standard, I think is what CIS stands for. But effectively, this is like, these are the best practices. And
Mm-hmm.
it's written up as a white paper. You can download it for free. We've had that for 6 months, but built into the host level operating system and available in the control container, you can run a checker on it, and it will evaluate all your settings and will report back to you in human readable form or a machine readable form that you meet those compliance levels or that you do not and what you need to fix.
I know
So
that's going to be so important for some people because they like to be able to run those CIS benchmarks, but obviously the way Bottlerocket is implemented, it's a little bit harder to just run arbitrary commands, because you have to have a control container to run.
Yeah.
You can't, there's no shell to run commands on. So I understand why this is necessary in order to allow you to run that CIS benchmark list of your choice and verify that Bottlerocket's actually configured the way you want it to be.
Yeah, absolutely. And I know we're running out of time, but the other big feature we have is ECS2. So up to this point, we've only had one variant for ECS since we launched with ECS a couple years ago. But ECS2 is bringing a lot of modern features to the system. We'll have a brand new kernel 6.1 of Linux kernel, cgroups v2, a lot of these great system level things that we weren't able to do, but it just kind of brings it up. So Kubernetes and ECS are really at the same level for Bottlerocket now. So that's really exciting. We hope a lot of ECS folks will do it. There was previously some problems when you launch a Bottlerocket instance, which is, by the way, very easy. From EKS, it's just an option. And then even in the control plane for ECS now, you just select Bottlerocket as your operating system. And you've got a Bottlerocket cluster with secure boot by default, with all of these things by default. You have to select the EC2 as your worker nodes besides serverless, but really simple to do that. So yeah, I think we're going to see a lot of ECS users take advantage of it, and it's such it's free real estate, right? You have like this thing where you do very limited changes and you gain so much from it.
100%. Well, I'm very excited about this. Excited to play around with Bottlerocket 1.15 hands-on myself with ECS. And thank you so much for giving us the masterclass in Bottlerocket and really operating systems in general.
I'm glad to. Yeah, and for those who want to follow up, bottlerocket.dev is a good place to go. You can look at Bottlerocket OS on GitHub. That's our organization, and you'll see everything there. And then you can see all the different features in 1.15. We have a tracking issue. We just closed it like probably a few hours ago. So that's exciting. And we have a meetup group that you can look to. It's linked on the GitHub repo where we have bi-weekly community meetings. You can ask us questions.
Fantastic.
Yeah, so we're interactive. So
awesome. Thank you very much, Kyle. Looking forward next time we have you on the show to talk some more about Bottlerocket or whatever exciting new topics you have. Thank you very much, everyone, for attending Containers from the Couch today, and see you around next time.